Hi, let's do some questions based on the Ksp molar solubility. So when we do the questions, we're going to have to look at what type of it is, AB type or AB2 type. So that way it would be easier. Let's look at this question. Calcium fluoride molar solubility is given. So S is given and our question is Ksp. So that's how you simplify the question, right? So typically we write the formula calcium fluoride solid at equilibrium, right? Calcium 2 plus and 2 fluoride anions, aqueous and ion products. Now you can also visualize the calcium 2 plus is something like a diamond here, and the two anions are by the side. So there's two anions, two pieces, and one cation, right? So that's something to visualize. Now, so typically you can start with the ratio, right? And you can actually put the rise table, or you can simply say minus S and 2S, write the Ksp expression, calcium 2 plus, square bracket, and fluoride, power of 2 because of the ratio 2, calcium 2 plus, and you can actually put the S here and 2S to the square. It becomes 4S cubed. That's the AB2 type problems, right? So now we just plug in the given molar solubility and to the power of 3, and voila, you will just plug in with the proper brackets and add the molar solubility, right? Not the gram solubility. So that will give you the answer for Ksp. So don't worry about the units of the Ksp. That's it, right? So how did we do it? You look at the givens and you look at what's the question asking, what's the answer, write the equation, pay attention to the ratio, and do the math properly, right? Okay, so let's look at the next question. So what's he's giving here? So lead iodate molar solubility is given, calculate the Ksp. Again, straightforward. This is the AB2 type, right? So again, so write the expression Pb2 plus, and iodate is a polyatomic anion, so the ratio tells me there is 2 iodates, right? So 1 1 2, so that 2 has to be there in the coefficients. So minus S and 2S. So write the Ksp ion products. So lead 2 plus, square bracket, iodate 2 to the power, right? Now we replace with the S's, S, 2S to the squared. You simplify 4S cubed. Now we need to plug in the S value, right? So S value is given, and our question, we are looking for Ksp. We are ready to go with this one, so plug in that one, right? Make sure the brackets are there, 4 times bracket, molar solubility 4.1 times 10 to the minus 5 and cubed, right? So plug into the calculator with the proper brackets and you should get this answer. Okay, so the next question, calcium carbonate gram solubility is given. It is given for 200 ml of water. That's the givens. Little complicated. How much? Show how to do the calculation for Ksp. So this is how you can write it. So this many grams diluted in 200 milliliter, saturated, right? And question Ksp. Again, write the formula calcium carbonate and calcium 2 plus carbonate minus, it's an AB system, straightforward, simple one, and 1 to 1 to 1, right? So that's the ratio. So we can put minus S and S. Again, Ksp expression, calcium 2 plus, carbonate, right? And then S to the S, that gives us S squared, right? And now we can plug in the molar solubility, but now we have a little bit of a math to do, right? So let's remove this question a bit to a side so we can do a bit extra stoichiometric part, right? So what's given? So we are given 1.38 times 10 to the minus 3 grams is in 200 milliliter. So milliliter, 1000 milliliter is 1 liter. And then in order to cancel the grams, we need the molar mass. So molar mass of calcium carbonate is 100.1. It's calcium 40, carbon 12, O3 is 48. It comes to 100, right? 100.1 exactly. Grams per mole, grams per 1 mole. Why we do that? We need to cancel this gram to this gram, this mil to this mil. You will end up with moles over liter. That is S, which is the molar solubility, right? Let's plug into the calculator. You should get 6.9 10 to the minus 5. Plug in there, take the squared value. So that should give you the Ksp for that temperature, that particular experiment done in that temperature. So that's the value we get. Okay. Now next question has a little bit more experimental side of a question, and this is specifically stoichiometry. So you want to have a sound stoic knowledge in order to do these questions, right? So let's get back the question that we put away. So I think that's the last question. Yeah. Okay. So here we are given an aliquot of 1 liter saturated solution, magnesium hydroxide evaporated to constant mass of this much. Calculate Ksp. So we do what we do normally, right? So calcium hydroxide dissociate into magnesium 2 plus and 2 hydroxides. So ratio 1:1:2 minus S to S, and expression Ksp hydroxide to the power of 2 and S2S to the square, that gives us 4S cubed. That's the AB2 type, right? So now, so that's the standard thing that we do, right? Now we need to figure out this S, the molar solubilities. How do we do that? So in these type of questions, this is the idea. So you have a beaker and you have a salt saturated solution. So that means there's a little bit of a solid settled down. It goes back and forth, dynamic equilibrium happening, ions and precipitation, it's going back and forth. We take only the solution, 1 liter, let's say it's easy, 1 liter, take it out, put it into a watch glass, right? You have only ions in this one. It's a saturated solution. So let's say you warm it, get rid of the water, evaporation, right? You remove all the 1 liter water. So what is left? In the watch glass, you're going to see a little bit of a dust or powder solid settled. So you warm it until constant mass, because you need to get rid of all the water. Now, so you can measure, weight 3 times and you get the constant mass, right? So once you have the constant mass, you can calculate the gram solubility. So here 0.0064 grams from 1 liter, that's what given, right? And so they can complicate the question saying initial mass and final mass and so on, right? Okay, so the magnesium hydroxide molar mass is 58.32, magnesium 23, 2 hydroxides 34, so you can add together. So we put the grams, 0.0064 grams in 1 liter and 58.32 actually grams per 1 mole, because we need to cancel the grams. We need moles over liter, right? So that's the moles over liter. We calculated, that's big M, moles over liter, that is S, the molar solubility. Now we are back to the normal thing. So this is a stoichiometric and little bit of more thinking to do. and that's how you want to do it, right? So we plug in that value here to the normal formula that we use, and so make sure you cubed first, brackets, cubed, and then times 4. So that'll give you this number. So check it out, the calculator, and you should end up with this one. So those are the questions for today, right? Now, if you have any more questions, you can send it to me, right? Or one of my students, and they will work it out. They will type it for me and give it to me. And then I can put it to the lazy notes, right? They want to call it lazy notes. So I have no problem with it. Yeah, okay. Thank you. See you next time.